Good morning everyone. So myself Sarthak Pal. Today I am representing our Babbage's group for operating system assignment, and our topic is to discuss about scientist Babbage. So when we first hear the name Babbage, it comes to our mind that Charles Babbage, and he is often referred to as the father of the computer, as we everyone know. And he was a very visionary mathematician, inventor, and a mechanical engineer also. He was basically born in 1791, and his work laid the foundation for the modern computing. And one of the Charles Babbage's most valuable contribution was his design for the analytical engine, a mechanical general purpose computer. Next, we'll move to the Charles Babbage's pioneer work in computer science. First is difference engine. Babbage designed the difference engine, a special category mechanical calculator which is basically used for to compute the polynomial functions, which is very useful for to modern calculators and tabulating machines. Next is analytical engine. One of the Babbage's most notable contribution was to design the analytical engine. Next is legacy. Charles Babbage's visionary ideas and designs are really unimaginable. We cannot compare it to others. Next is the analytical engine and the Babbage's vision for the future. First is programmable architecture. Babbage's analytical engine designed a future programmable architecture which is allows to be reprogrammed to solve a wide range of computational problems. Next is foresight and innovations. Babbage's revolutionary ideas about the future of computing, including the concept of stored program architecture, were decades ahead of their time. Influence of computer science. Babbage's work inspired later pioneers in computer science, paving the way for the development of the modern computer science. So in this way I am concluding my lecture. Thank you.
Good morning everyone. Myself Utkarsh Kishan and we the members of Group Babbage are here to present the topic Race condition and critical section problems. Race condition and critical section problems are the two most common problems that arise in the world of computer systems and software development. These concepts are fundamental to understanding how multiple processes or threads can access and manipulate shared resources. Now, what is a race condition? A race condition occurs when two or more threads or processes share data simultaneously and their execution order affects the outcome. Just like the example given on the left side, imagine two threads racing to modify the same variable. If one thread checks the value and then acts based upon it, another thread might change the value in between, leading to unpredictable results. To prevent race conditions, locks or other synchronization mechanisms can be used to ensure only one thread can access the shared data at a time.
Hello, my name is Tariful Sheikh. So I discussed about what is a critical section. A critical section is a part of program, typically a few lines of code where shared resource like a variable data structure or a hardware are accessed and modified to prevent race condition where multiple processes or threads attempt to access, change, shared resource. A critical section must be executed as an atomic action. This means that only one process or thread can execute the critical section at a time. First of all, shared resource access. A critical section is a part of program or algorithm where a process or thread accesses a shared resource such a variable, file or data structure. Next, exclusive access. A critical section it is a crucial that only one process or threads can access the shared resources at a time to maintain the integrity and consistency of the data. Potential for conflict. If multiple processes or thread attempt to enter the critical section simultaneously, it can lead to race condition and other synchronization issues resulting in unpredictable behavior and potential data.
The necessary conditions for a synchronization problem is the critical section and race condition and premature preemption. And we also know the requirements of the critical section problem is mutual exclusion, progress and bounded waiting. So what is mutual exclusion? Mutual exclusion, if a process is executing in its critical section, then no other process can be executing in their critical section. Now, what is progress? If no process is executing in its critical section and some process wish to enter their critical sections, then only those processes that are not executing in their remainder section can participate in deciding which will enter its critical section next, and this section cannot be postponed indefinitely. Now, what is bounded waiting? There exists a bound or limit on the number of times that other processes are allowed to enter their critical section. After a process has made a request to enter its critical section and before that request is granted.
Hello, myself Shartapal. We will discuss about the conclusion of these slides. So first of all, I will discuss about the importance of understanding. Understanding the race conditions and the critical section problem is very much essential for designing and implementing of reliable computer systems and the softwares. Next is practical applications. The techniques used to solve the critical section problems such as mutual exclusion, bounded waiting, and the dead clock avoidance are widely used in various computing domains like operating system and database management system. Next is ongoing challenges. As computer systems become more complex and it's more critical, the challenges posed by race condition and the critical sections problems continue to evolve. So in this way, we are concluding our presentation. Thank you.